Today topic is, time and space complexity of Turing machines. Measuring complexity. Suppose that we have a decider D for some language L. How might we measure the complexity of D? Number of states. Size of tape alphabet. Size of input alphabet. Amount of tape required. Number of steps required. Number of times a given state is entered. Number of times a given symbol is printed. Number of times a given transition is taken. Time complexity of Turing machine. A step of a Turing machine is one event where the Turing machine takes a transition. Running a Turing machine on different inputs might take a different number of steps. The figure shows calculations of time complexity of Turing machine. Based on the input tape, input should be read and check the state machine. The input accepting means transitioning into special state. Time complexity of Turing machine. The number of steps a TM takes on some input is sensitive to the structure of that input, the length of the input. How can we come up with a consistent measure of a machine's runtime? The time complexity of a Turing machine M is a function, typically denoted f of n, that measures the worst-case number of steps M takes on any input of length n. By convention, n denotes the length of the input. If M loops on some input of length k, then f, k, equals infinity. The previous Turing machine has time complexity f of n, equals n plus 1. Any input of length n of the form 0 1 0 1 0 halts after n plus 1 steps. Some inputs may take less time to halt, but time complexity considers the worst case complexity. Space complexity for Turing machine. Space complexity is a critical concept in computational complexity theory. For a Turing machine, it refers to the amount of tape cells the machine uses during computation, as a function of the input size. While time complexity measures how many steps are taken, space complexity measures how much memory is required. Space used by Turing machine M on input word W, denoted as S, MW, is defined as the number of tape cells that were visited by the head before M halted. If M does not halt, it is not defined. We say that f, n rightward arrow n is space complexity of M, with stop property, IFF turned a n set membership symbol n, f, n, equals max s, mw, w set membership symbol sigma n. Example of time complexity of Turing machine. Consider input tape length n. Each scan takes n steps, x belongs to 0 power n 1 power n. The overall running time is order of n square. Optimal solution for one tape Turing machine order of n log n. Space complexity example. Space complexity of the following input. X belongs to 0 power n and 1 power n. Make the input tape as read-only tape. How much space it require for computation? If it uses tape as a stack, it requires order of n cells. Add binary counter logic to the Turing machine. If n is equal to 64, it takes log 2 of n equal to 7 bits in binary to keep the count. So we can solve it using big O log n space.